Today I want to talk about high efficiency forced air natural gas furnaces. Furnaces like this, how do you know if they're high efficiency at a quick glance? If you look in behind the unit right here, you'll see that these pipes coming off, these are your flue pipes. They're made out of plastic. High efficiency units, your exhaust temperature from burning the natural gas is low enough that it won't melt plastic pipes. So that's how you typically know at a quick glance that these are high efficiency. If this was mid efficiency or less, these would be made out of metal because your exhaust temperatures are much higher. When you're taking a look at high efficiency furnaces, I always pop the top cover off and set it off to the side. On the inside of a furnace, with high efficiency, the first thing that really jumps out at you that there's a problem is you would look for water damage. With this one here, it's dusty and there's some cobwebs in it, but you don't see any signs of any water. With high efficiency furnaces, anytime you burn natural gas, your byproducts are carbon monoxide and water. So the water actually comes down through a drain here, it turns, goes into this pump, and then the pump is pumping it over to a laundry tub. The most common problem I see with furnaces like this is when the drain gets clogged, water will back up and then flood out into the system here. The biggest problem that you run into when things like that happen is that water is going to do one of two things. This little fan motor that you see right here, your venter motor, this is supposed to put the carbon monoxide in the flue pipe and send that outside. If there's water holding in the bottom of the blower or in the venter motor, what you'll find is it will overwork the motor and the motor will burn out. It will get too hot and it will just burn out. Venter motors, depending on who does the work for you to replace them, typically runs around $600 to $700 or $800. The other problem that you run into when the drains are clogged, if that water backs up, you'll notice the control card is right here. Electronics, anything with electricity and water, don't usually get along very well. So if I have a clog in the drain and that starts to drip down onto my controller, this machine's not going to run anymore. And control cards, they're pretty expensive too. They're typically in the $600 mark as well. Taking a quick glance at this, yeah, it's a little dusty and a little dirty, but there's nothing wrong with it. It looks fine. Second thing I always do is I look on the inside of the unit to find out when it was made. With units like this one, you can look at either the serial number or on this one it says right on it, it was made in November of 2011. High efficiency furnaces, I find with these the average lifespan that you will see is roughly 20 years. They should last about 20 years. I see some that are older than that and I see some that are younger than that. Usually the ones that you hear people say, oh, my furnace only lasted me 10 years. It's because that drain got clogged, the cost of a venter motor and a controller, it just wasn't worth repairing, so you'll see people replace them when that happens. But usually I will typically see furnaces make it up to about 20 years, and then once you're over 20 years, you're kind of running on borrowed time. You should expect that you'll have to change it out if it's anywhere near the 20-year-old mark. At 20 years old, let's say you had a problem with your venter motor. Is it worth spending $600 to $1,000 to get that fixed when a new unit is about $3,500? You know, you can get some a little cheaper or some a little more expensive, but spending $1,000 to fix something that may a month later have a problem down here or a problem back in here, I usually tell people if you have an expensive problem on a unit that's around the 20-year mark, it's not worth repairing. You should probably just replace it. Other things you check. You look at the filter. This one here, 16 by 25 by 1 inch filter. This is pretty dirty. This is due for replacement. Before getting started, I sat one out to the side just to show you guys how easy this is to put in. 16 by 25 by 1 inch filter. I like these ones because they've got the wire mesh reinforcement. As you're drawing air through this, the opportunity for this to get sucked out by the house fan in the bottom is much lower. So I do like the ones with the wire mesh backing. The other thing to remember with this too is they are directional. The arrow that you see right here is for the direction of airflow. You always want that arrow to point towards the machine. So when I slide that in, I've got a nice new filter in there. Filters, change them every 3 to 4 months with the 1-inch filters. If you have wider filters, you can get more time out of those. Next up, we're going to run this and make sure everything fires up and runs okay. This is the thermostat. A thermostat's job is to tell the furnace or the air conditioner to turn on or off. With this thermostat here, currently, it's set to off. My inside temperature is currently at 15 degrees Celsius, which is pretty cool. Typically, room temperature is about 20 to 22 Celsius. So what I'm going to do is I'm going to flip this over to heat, because we're checking the furnace today. So we're going to flip that over to heat. We can see the inside temperature setting is at 15. We're going to bump that up to 20. And then we're going to go downstairs and watch the furnace run. If you listen, I can actually hear the furnace has already started, so I know this is working. Now that I've got the furnace turned on, things that I want to look for while this is running, this is your venter motor. Remember I said if there's a problem with the venter motor, we won't be getting the carbon monoxide out of the house. So this is turning right now, and it sounds good. It essentially makes no noise at all. Sometimes your venter motors, they'll make a loud squeaking noise. That usually means that they're on their way out and they're going to need to be replaced. But this one sounds really good. Up in here, this is where your burners are. With this one here, there are 2 burners, and I can see the flames are nice and blue. They're very controlled looking. When I look on my ID tag, it tells me that it's a 40,000 BTU unit. That means there's 20,000 BTUs per burner. Those are burning nice. There aren't any obnoxious sounds coming from the machine. So this is running good. Okay? House fan is turning. Venter motor's turning. The flames look good. So I'd say for this unit, you're in good shape. When checking the heating system on a house this age, you always want to make sure there's no asbestos anywhere on the ductwork. This right here behind me is one of the risers that goes upstairs. If there was asbestos on this, you'd see a white fabric wrapped around these pipes. This is just galvanized steel. There's no insulation on top of it, no signs of any asbestos. So that's good. So now that we've taken a look for any asbestos on the ductwork, how do we make sure that there's heat getting into the individual rooms? With this house here, the heating register is in the wall right here. If I put my hand in front of it, I can feel warm air coming through it. I definitely know that this is working. But just to be on the safe side, I want to make sure that there is enough air. So what I do is I use what's called an infrared camera. With this camera here, I can put it right on the register, and I can see that I'm getting 37 degrees Celsius coming up from the duct. 37 is good. If our target room temperature is 20 and we have a difference of 17 degrees Celsius, we know that that room is going to eventually come up to temperature. And that's good. That's what we want to know. So what can we say about the furnace that we were looking at today? It's a high-efficiency forced air natural gas furnace. It puts out 40,000 BTUs, which for a house this size, it's a smaller, well-insulated bungalow. This is the right size. It was made in 2011. Today it's 2020 this year, so looking at this, we know it's 9 years old. At 9 years old, your typical lifespan on a high-efficiency forced air natural gas furnace like this one is 20 years. So you should get 10 to 11 more years out of it. It's definitely possible to get more with a maintenance program from a heating and air conditioning company. If you went on an annual service program where they come in the fall and they get it all ready to go for the winter, you would definitely get more than 20 years out of this. Or with this one, 11 more years out of it. But it's running great. There's no asbestos. The distribution of heat through the house was good. This is a good system.